Our planet Earth is a place of wonder. Born from swirling dust and gas, our young planet was a hostile place. Volcanoes erupted, spewing molten rock and noxious gases. Water vapor condensed to form vast oceans, the cradle for the miracle of life. The Earth's journey from a fiery inferno to a life-sustaining haven is a testament to the power of time. In the grand tapestry of the cosmos, our planet stands out, a beacon of life. From single-celled organisms to the complex diversity of plants and animals, life on Earth has transformed. The first life forms were microscopic, single-celled organisms in Earth's early oceans. These pioneers harnessed energy from the sun and chemicals in their environment. The emergence of photosynthesis led to the release of oxygen, paving the way for more complex life. Life on Earth is a branching tree, with countless species evolving and disappearing. From oceans to mountain peaks, life has adapted and thrived. Our journey through time will take us from the first single-celled organisms to the rise of dinosaurs and mammals. We will explore major eras in Earth's history, each marked by significant events. Fossils provide invaluable clues about ancient life, their anatomy, behavior, and environments. We will explore the rise and fall of ecosystems, understanding the balance of life. By studying the past, we gain a deeper understanding of the present and future. Join us as we embark on this adventure through time. Our journey begins almost 4 billion years ago, in the Precambrian era. The continents were barren expanses of rock and volcanoes. Within Earth's primordial oceans, simple organic molecules began to assemble. These molecules, formed from the sun's energy and volcanic activity, were the precursors to life. The emergence of life from non-living matter, known as abiogenesis, is a profound mystery. Evidence suggests it occurred in these early stages of Earth's history. For billions of years, life on Earth existed in single-celled forms. Around 2.4 billion years ago, cyanobacteria emerged, performing photosynthesis. Photosynthesis released vast amounts of oxygen into the atmosphere. This led to the Great Oxidation event, a turning point in Earth's history. The rise of oxygen paved the way for the evolution of more complex life forms. The Great Oxidation event had a dramatic impact on the planet's chemistry. Prior to the Great Oxidation event, life was limited to single-celled prokaryotes. Around 2 billion years ago, eukaryotic cells emerged with complex internal organization. Eukaryotic cells paved the way for multicellular organisms. The prevailing theory suggests they arose through endosymbiosis. A prokaryotic cell engulfed another, evolving into an organelle within the host cell. This was a major leap forward in the evolution of life. As oxygen levels rose, life continued to evolve. Stromatolites, layered mounds of sediment formed by cyanobacteria, represent early evidence of life. They were widespread in the Precambrian oceans, forming vast reefs. Stromatolites were instrumental in oxygenating the atmosphere. Today they are found in isolated locations, serving as living fossils. These structures stand as a testament to the enduring power of life. The Paleozoic era marks a dramatic turning point in the history of life. The Cambrian Explosion saw an unprecedented burst of diversification. Early creatures, preserved as fossils, were unlike anything seen before. Trilobites, armored creatures, and giant predators emerged. The Cambrian Explosion laid the foundation for complex ecosystems. It marks the beginning of the incredible journey of life's diversity. Following the Cambrian Explosion, life in the Paleozoic oceans evolved. The Devonian period is known as the Age of Fishes. Placoderms, armored fishes, were apex predators. Lobe-finned fishes possessed fins resembling limbs, paving the way for land vertebrates. The Devonian period saw great evolutionary innovation in the seas. It was a time of intense competition and adaptation. During the Paleozoic era, life began to colonize the land. The first pioneers were plants, appearing around 470 million years ago. Early plants altered the environment, making it hospitable for other organisms. Insects followed, taking advantage of the new habitat. Vertebrates gradually transitioned from water to land. Early tetrapods, like Tiktaalik, possessed adaptations for land and water. The Paleozoic era ended with the Permian-Triassic extinction event, the Great Dying. This event wiped out 96% of marine species and 70% of terrestrial vertebrates. Causes include volcanic eruptions, global warming, and ocean acidification. The Great Dying drastically reduced biodiversity. It took millions of years for life to recover. The Permian-Triassic extinction highlights the fragility and resilience of life. The Mesozoic era marks a dramatic shift in the story of life. Reptiles diversified and dominated after the Permian-Triassic extinction. Archosaurs, including dinosaurs, pterosaurs, and crocodilians, emerged. They possessed adaptations for efficient locomotion and advanced respiratory systems. Archosaurs outcompeted other reptile groups, dominating terrestrial ecosystems. The stage was set for the rise of dinosaurs, ushering in the Age of Giants. The Jurassic period, commencing around 201 million years ago, marked the beginning of the dinosaurs' reign as the undisputed masters of the planet. Earth's landscapes transformed into a breathtaking panorama of colossal creatures, their massive forms casting long shadows across the land. Giant herbivores such as Brachiosaurus and Diplodocus, with their long necks and thunderous footsteps, roamed the plains, while fearsome predators like Allosaurus stalked their prey through dense forests of ferns and conifers. The dinosaurs' success can be attributed to a combination of factors, including their upright posture, efficient locomotion, high metabolic rates, and remarkable adaptations for growth and reproduction. Their bones, often lightweight yet strong, allowed them to attain sizes that dwarfed those of any other land animals before or since. The reign of the dinosaurs spanned over 135 million years, encompassing the Jurassic and Cretaceous periods. During this time, they diversified into a bewildering array of forms, from the heavily armored ankylosaurs to the swift, feathered raptors. Their fossils, unearthed from every continent on Earth, paint a vivid picture of a time when giants ruled the planet. The Age of Giants was not without its challenges, however. Volcanic eruptions, asteroid impacts, and shifting continents continually reshaped the Earth, forcing the dinosaurs to adapt to ever-changing environments. Yet, they endured, their reign lasting until a cataclysmic event from space brought their era to a dramatic close. The Mesozoic era wasn't just the age of dinosaurs, it was also a time of profound change in the plant world. During the Triassic period, the dominant plants were gymnosperms, a group that includes conifers, cycads, and ginkgos. These plants, with their naked seeds and wind-pollinated cones, had already begun to diversify in the late Paleozoic. However, during the Cretaceous period, a new group of plants emerged that would revolutionize life on Earth, the angiosperms or flowering plants. Angiosperms possessed a number of key innovations that gave them a competitive edge over gymnosperms, including flowers for attracting pollinators, fruits for dispersing seeds, and more efficient vascular tissues for transporting water and nutrients. The emergence of flowering plants had a profound impact on terrestrial ecosystems. Their flowers provided a new source of food for insects, while their fruits attracted a variety of animals that helped to disperse their seeds. This coevolution between plants and animals led to an explosion of diversity in both groups. By the end of the Cretaceous period, angiosperms had become the dominant plants on Earth, shaping the landscapes and providing the foundation for the diverse ecosystems we see today. Their evolution was a key factor in the success of many animal groups, including mammals, birds, and insects. The Mesozoic era ended abruptly around 66 million years ago. An asteroid about 6 miles wide hit near the Yucatan Peninsula. altering life on Earth. The impact released energy equivalent to billions of atomic bombs. Shockwaves triggered earthquakes, tsunamis, and volcanic eruptions. The aftermath was catastrophic, with long-term consequences. Dust and debris blocked the sun, causing darkness and cold. This impact winter devastated life, especially dinosaurs. The extinction event ended the dinosaurs' reign, starting the Age of Mammals. The catastrophe allowed new life forms to evolve and diversify. The Cenozoic era, beginning 66 million years ago, marks the Age of Mammals. With dinosaurs gone, mammals emerged from the shadows ready to inherit the Earth. Their warm-blooded metabolism and adaptability gave them an advantage. The early Cenozoic saw rapid diversification of mammals. Small creatures evolved into diverse forms, filling ecological niches. The Cenozoic era, while often referred to as the Age of Mammals, was also a time of dramatic climate change, marked by a series of glacial cycles that profoundly impacted the evolution of life on Earth. Beginning in the late Eocene epoch, around 34 million years ago, global temperatures began to decline, ushering in a period of cooling that would culminate in the Pleistocene epoch, often referred to as the Ice Age. During the Pleistocene, vast ice sheets, originating at the poles, advanced and retreated across continents, carving out valleys, sculpting mountains, and altering the distribution of plants and animals. These glacial cycles had a profound impact on the evolution of life, driving adaptation, extinction, and the emergence of new species. Many animals evolved adaptations for surviving in cold, harsh environments, such as thick fur, layers of blubber, and behavioral adaptations like hibernation and migration. Iconic Ice Age animals like the woolly mammoth, the woolly rhinoceros, and the Irish elk roamed the frozen landscapes. Their massive forms adapted for conserving heat and foraging for scarce vegetation. The Pleistocene glaciations also had a profound impact on human evolution. Our hominid ancestors, forced to adapt to the challenges of a changing world, developed sophisticated tools, learned to control fire, and migrated across continents, their resilience and ingenuity paving the way for the emergence of our own species, Homo sapiens. Amidst the grand evolutionary tapestry of the Cenozoic era, a remarkable chapter unfolded. The rise of the primates, the order of mammals to which we humans belong. Our story begins in the lush rainforests of the Eocene epoch, around 56 million years ago, with the emergence of small arboreal creatures that possessed a unique suite of adaptations for life in the trees. These early primates, though they would have seemed unremarkable compared to the giant mammals that roamed the earth at the time, possessed a number of key features that set them apart from other mammals and laid the foundation for our own evolution. Their grasping hands and feet, with opposable thumbs and big toes, allowed them to deftly navigate the branches of trees, while their forward-facing eyes provided them with enhanced depth perception, crucial for judging distances in a three-dimensional world. Over millions of years, primates diversified into a variety of forms, each adapted to its own ecological niche. Some, like the lemurs and lorises, retained their primitive features, while others, like the monkeys and apes, evolved larger brains, more complex social structures, and enhanced cognitive abilities. The primate lineage, shaped by the forces of natural selection, embarked on an evolutionary journey that would eventually lead to the emergence of consciousness, language, and culture, the hallmarks of our own species, Homo sapiens. The story of humanity is a tale of resilience and an unyielding quest to understand our place in the cosmos. Our journey begins in Africa 6 to 7 million years ago with the divergence of hominids from chimpanzees. Early hominids walked upright, freeing their hands to use tools and interact with their environment. This innovation, along with expanding grasslands, opened new opportunities for our ancestors. Over millions of years, hominids diversified, leading to species like Australopithecus, Afarensis, and Homo erectus. The journey to Homo sapiens, emerging around 300,000 years ago, was complex and non-linear. Our species, with large brains and complex language, inherited a legacy of adaptation and innovation. Throughout the eons, life on Earth has been a continuous dance between creation and destruction, innovation and extinction. While the emergence of new species and the diversification of life are celebrated chapters in our planet's story, there have also been periods of profound loss, times when the tapestry of life was rent asunder. These catastrophic events, known as mass extinctions, have punctuated the history of life, reshaping ecosystems and altering the course of evolution. Mass extinctions are defined as periods when a significant portion of Earth's biodiversity disappears in a relatively short geological time frame. These events are not merely accelerated background extinctions, the normal ebb and flow of species coming and going, but rather represent dramatic upheavals that fundamentally reset the evolutionary clock. The causes of mass extinctions are varied and complex, often involving a confluence of factors that disrupt Earth's delicate balance. Volcanic eruptions, asteroid impacts, climate change, and changes in sea level or ocean chemistry can all trigger cascading effects that ripple through ecosystems, pushing species beyond their limits of tolerance. While mass extinctions are periods of immense loss, they also create opportunities for new forms of life to emerge and diversify. In the wake of these catastrophic events, survivors inherit a world transformed, their evolution shaped by the challenges and opportunities presented by the new order. The Ordovician period, spanning from 485 to 443 million years ago, saw remarkable ocean diversification. Life flourished in warm, shallow seas with trilobites, brachiopods, and corals. This prosperity ended with the Ordovician-Silurian extinction event. A dramatic climate shift plunged Earth into an ice age. Rapid environmental changes led to widespread extinctions. The Devonian period, known as the Age of Fishes, saw remarkable fish diversification. Armored placoderms, early sharks, and lobe-finned fishes thrived in warm, shallow seas. Environmental catastrophes led to the late Devonian extinction, one of the big five mass extinctions. Causes include ocean anoxia, global cooling, and possibly an asteroid impact. Rapid plant growth led to nutrient runoff, causing algal blooms and dead zones. The extinction wiped out many marine organisms, paving the way for new life forms. The Permian-Triassic extinction event, occurring around 252 million years ago, stands as the most catastrophic mass extinction in Earth's history, a somber testament to the fragility of life in the face of extreme environmental upheaval. This event, often referred to as the Great Dying, wiped out an estimated 96% of marine species and 70% of terrestrial vertebrate species, leaving the planet's ecosystems in ruins. The causes of the Permian-Triassic extinction were multifaceted, a perfect storm of cataclysmic events that conspired to push life to the brink. Massive volcanic eruptions in what is now Siberia spewed out colossal amounts of lava and greenhouse gases, poisoning the atmosphere and triggering runaway global warming. The rising temperatures melted methane hydrates, frozen deposits of methane gas trapped beneath the ocean floor, releasing even more greenhouse gases into the atmosphere and further accelerating global warming. The oceans absorbed much of this excess carbon dioxide, leading to ocean acidification, which had a devastating impact on marine organisms, particularly those that built shells and skeletons from calcium carbonate. The Permian-Triassic extinction event was a defining moment in Earth's history, a stark reminder of the power of nature to reshape the biosphere. It took millions of years for life to recover from this catastrophic event, and the world that emerged in the aftermath was vastly different from the one that had existed before. Our journey through Earth's 4.6 billion years of life evolution is a testament to time, adaptation, and interconnectedness. From single-celled organisms to today's diversity, evolution is constant change and resilience. The Cambrian Explosion laid down blueprints for major animal groups. The Permian-Triassic extinction shows life's fragility and nature's power. Life endures, adapting and evolving through countless pathways. The fossil record chronicles the rise and fall of species. Life's story continues to unfold around us every day. Each discovery adds a new thread to life's intricate tapestry. As we've journeyed through time, we've come to appreciate the interconnectedness of all living things. We are inextricably linked to the organisms that came before us, our own existence shaped by the evolutionary forces that have driven life's journey for billions of years. Understanding Earth's history is essential for comprehending the challenges facing our planet today. By studying the past, we gain insights into the potential consequences of climate change and habitat loss. The lessons learned from Earth's history can guide us in our efforts to conserve the planet's biodiversity. The story of life on Earth is still being written, and we have a profound responsibility to shape the next chapter.